Hey everyone, welcome to the second topic of the week um, on thinking and language. This is a little bit of a shorter kind of combo than memory was, but it's still pretty relevant to what we, basically thinking is just, cognition. If you ever hear the term cognition, thinking, it's the same thing: problem solving, decision making, judgment. All those things that we do on a regular basis is what we're going to kind of talk about, is like how we go about those thinking patterns and those decision making, problem solving techniques that we use really all the time. So it's divided into three total videos: two on thinking, one on language, and we'll get started right now. Okay. So, like I said, thinking is just cognition, and you can see the definition there: the mental activities, processes um, that are associated with thinking, knowing, remembering, and communicating information. So, anytime that you remember something and then use what you remember to make a decision, or use information that you already have in your mind to make a decision or come to a judgment or decide solve a problem, like that is cognition. That is using what is in your mind, what is in your consciousness, to make a decision, to judge something about a situation or a person or a scenario, to solve a problem that you may have, whether it's in school or in social relationships, or um, you know, any split second decision that you make. I mean, all of that stuff is falls under the tree of cognition and thinking. It's really anything in which thinking patterns are involved, basically. So anyway, um, a couple of things that we use when we make judgments or decisions. Mental images. This is one of those things that um, you don't really have very early on. We very briefly mentioned this when we talked about Piaget back in developmental psychology, in that as children, whenever we're able to form mental images, we can think about things that aren't like right in front of our face. So, for example, if you ask somebody, or if you ask a child what a house looks like, they may not be able to tell you unless they can point to a house that's right in front of them. But once they get the ability to create a mental image, it is it's just a mental picture, quote unquote, of a previously stored sensory experience. So once you see something and you think about it again in the future, it's not right in front of your face, but you are thinking about it and you are having that mental image in your mind. But I know you hear mental image, a previously stored picture, and you immediately think visual. And while yes, it's absolutely, it can be visual, but it can be any sensory experience. Um, Sounds, smells, touch, taste, anything. Um, when you think back to it and you are able to imagine it in your mental state, then that is a mental image. When you think about a meal that you had that you really enjoyed, it was so good, and you think about that taste that of the food, that's a mental image. If you think about the smell that you had when you went to some kind of flower garden, that smell in your memory, that's a mental image. And kind of going back to the memory side, like these can help. We sort of talked about this with context dependent memory. These can help jumpstart memories from your long term memory to come to your short term memory by having these mental images, and they can help you recall information very quickly. But a mental image, again, is just a mental picture or experience. Excuse me, a mental picture or um, image of a previously experienced sensory experience. A previous sensory experience is a better way of saying it. Yes. Um, and again, it can be, usually we think visual a lot of times, but it can be any sensory experience. Okay. All right. Concepts. This is very similar to the idea of a schema under Piaget's theory. In fact, they're basically the same thing. It's just that Piaget called his schemas and non-Piaget people call them concepts. Um, but that's just a mental category that we use to group objects, events, information, situations that have similar features or characteristics. So it can be anything. It can be very specifically defined, like a school term or something, in like an education class, or not an education, any class, or it can be like something that is just an experience rather than like a definition. Um, but when we think about things like, just as example, when we think about things like um, cars, we're able to give you examples of what we know to be cars, or houses, or emotions, or it doesn't have to be an actual. It can be anything. It can be, you know, um, it can be an object. It can be an experience. It can be a situation. It can be an event. It can be types of people. It can be an emotion. It can be anything. Um, but that's the concept, is like what we use to group similar objects, events, blah blah blah, fill in the blank, that are similar in nature. Like whatever that concept is, we group those similar examples of that concept together because of how similar they are to one another. Okay, so and these are usually divided into two types of concepts. There's artificial slash formal, basically the same thing, artificial or formal concepts. These are specific rules, specific features. So, obviously when you the concept of like geometric shapes, that's, those shapes are like, what a square is, what a pentagon is, what a octagon is. Like they're very, very specifically defined. There's only one example of a square. There's only one example of a pentagon. Like it's a pentagon. It's a square. Like there's no other. Those are artificial, excuse me, formally defined concepts. And then there's also natural concepts, which are more kind of naturally formed. These are more based off experiences and definitions of our own experiences, rather than the definition of from like a textbook, or from a subject or whatever. So, like I said, vehicles, birds, fruits are the examples I put there. Anything, like, obviously, if you've never been around, or you've never heard of a certain bird or a certain fruit, you wouldn't use that as an example, because it's not a natural concept to you, because you've never experienced it naturally. You may be able to, with an artificial or a formal concept, you may be able to fill it in if you know what that is. So you may be able to fill in an example of a geometric shape that even if you've never actually seen one in reality or seen one in your own life. But because you know what the formal definition is, you can fill it in. With a natural concept, if you haven't experienced it, or you don't really know what it is through your own natural experiences, you may not be able to use a specific example for that concept. Okay. Um, on that same note, a prototype is you hear the term prototype a lot, but it's not really used the same way in psychology as it is everywhere else. Like a prototype is like if the best way I can explain this would be like, if you um whatever the first thing that pops into your mind about a particular concept. So if I ask for the prototypical or the prototype of a pet, then whatever pops into your mind in your instance of like the most typical or obvious example of that, which in this case would be a dog, you know, um, at least in my opinion, it would be a dog. That's my prototype for what a pet is. If you're a weirdo and a cat pops into your mind, then I'll keep you in my thoughts. But it could be anything. Literally, I mean, if you've only grown up around reptiles as your only pet ever, then that's going to be your prototypical pet, because that's all you know. Um, or it says there like a car would be the for a vehicle. I mean, if you say what a vehicle is, you'd probably say car. Maybe a bike. I don't, it can be prototypes don't have to be universal. Prototypes are specific to individuals. Um, and again, those are based on those natural concepts that we may have experienced in our own life already up to that point, or up to the point that you think about what a prototype is. Um, a couple of years ago, I think it was a couple of years ago, there was a question on the AP exam. I remember, going back and after they released the exam, going back and looking at it, and it it said something about, if you ask someone, what the best example of a flower is, and they say rose, then what is the rose? And the answer was prototype, because they were trying to get you to think about like what the best example of that particular concept was, and flower was the concept, rose was the prototypical or prototype of the flower. All right, so these are just right off the bat, real quick. These are not the only four ways that you can solve problems, but these are the four ways that we talk about in psychology, and they're very simplified ways of problem solving. And I'll go through each of them in a little more detail over the next couple of slides. But trial and error, insight, algorithms, and heuristics. Um, Trial and error and insight are pretty basic, like very, there's not a lot of ways you can really spin that into different scenarios. Algorithms and heuristics, you can get a little bit, you can get into some different examples of that. But so anyway, like with trial and error, well, actually, you know what? I'm just going to go through each one on the next slide. You can come back and look at these, and I'm essentially going to go over this information again. So trial and error is just basically trying things, and if it fails, you try something else. This is not just randomly doing stuff until something works. That's not what trial and error is. Trial and error is you trial using different solutions to problems. If one works, great. If it doesn't work, you move on to the next one, or you move on to a different scenario. So that's one example. So like it says there, if it doesn't work, call it version 1.0 and move on, try something else. It works well with inventions. It says there, like, it works well with inventions and trying things for the first time. But if something has a very clear solution to it, or a very clear type of solution to it, you're going to go down that path. You're not going to just try things that are obviously not going to work. So trial and error works well when you're trying to like invent things and using things for kind of the first time. But like if there's something that like, there's a very clear type of solution, then trial and error is not the way you're going to go about solving it. You're going to go about the very clear way. Insight, it's very, we sort of talked about this with learning when we talk about insight learning, where you just kind of have an aha moment, sudden realization, sudden flash of understanding. That's insight. There's really not a lot to go over other than that. Like when you are trying to solve something and you just kind of have that light bulb go off over your head, like the sudden realization or the aha moment, if you will, that's insight. Not everybody has the same level of success with insight. Sometimes people are more more apt to try other, because they don't have this very often, so they just try other types of problem solving. So anyway, so yeah, insight. There's just not a lot to say about insight. It's just very kind of straightforward. So these are the two where you can get um, uh, very different types of both of these, algorithms and heuristics. And we're going to talk about some ways that heuristics can cause you to have faulty thinking in the next video. But algorithms are very logistical, step-by-step procedures that you follow until you come to a solution. And they're usually written, and if you look off to the right here, right underneath where my incredibly weird looking face is. But if you look here underneath it, like the problem is that the lamp doesn't work, and you see it goes step by step through it, and the greens would be solutions to the problem. And if it doesn't, if that's not the solution, then you move on to if it then you do that. It's a step by step process. You will always arrive at a solution. It might not be the solution you want, and it might not be the best solution, but it is a solution. Mathematical formulas are like this. You plug stuff in, and you get to a solution. These are not good for these are not good for like quick thinking type of decisions. These are not good for kind of making decisions in social settings. Like normally you're not going to like literally go through step by step, but they're usually not efficient, or excuse me, they're not practical. They're efficient in that they always arrive at a solution, but they're not practical for everyday use and in every situation. And then heuristics are kind of shortcuts in thinking, and this is when you kind of reduce the possible numbers of solutions to arrive at a correct, or let me back up. It's when you reduce the number of possible correct solutions to make it easier to arrive at a decision. It's fast, and for an example of a heuristic would be like, if you are, let's say you and your group of friends are trying to try to figure out where to go, get when all this quarantine stuff is over and you guys are hanging out again, and you're trying to decide where to go get dinner. But you're probably not going to go, like, if you were using an algorithm, you would go through every single type of food and then choose from those groups. That would be, you literally go through every possible restaurant until you arrive at the one that you want. Heuristics would be like getting rid of the ones you're not going to go to for sure and reducing the number of correct possible solutions. It doesn't mean that you necessarily, arrive at the, best possible answer, but you arrive at an answer quickly. The other example there at the bottom would be like, obviously when those of you that are seniors, hopefully you're watching this video and participating, but we'll see. If you when you're trying to figure out where you want to go to college, you're probably not going to visit every single college in the country and then make your decision on that. It'd just be impractical, and you're not going to go through every single one. Like, there's, what you want, you have preferences, the things that fit your mold for what is the school you want. So you only look at the ones that fall in those parameters. You reduce the number of correct possible solutions, and therefore it's quicker, it's faster, it's more efficient at arriving at that problem. The downside to heuristics is that sometimes you might eliminate a better solution. If you don't, hypothetically speaking, if you don't go visit every single college when you're trying to make your decision, then there will always be a chance that one of those colleges was a better fit for you. But you decided to eliminate that from your list of possible solutions, and therefore it wasn't in consideration. So you arrived at a decision quicker, and it was more efficient, but it might be error prone because of that. So when we take shortcuts in our thinking, it doesn't mean that we arrive at a wrong solution, but there's always the chance that that we arrive. There's always the chance that we have eliminated a better solution because we took a shortcut, is what I'm trying to say. Hopefully that made sense. All right, so that's it for the first video. The second video will basically take some of the stuff we learned in this and talk about how there are problems with it, and some problem solving problems, quote unquote, if you will. And that's the next video. So we'll see you then.